In the first lesson, we learned about a type of reasoning called inductive reasoning, where you use patterns and take an educated guess based on what you've seen. Deductive reasoning is a different type of reasoning where we use facts, definitions, properties, and laws of logic to form a logical argument. So this is going to be the one that we're focusing on most in geometry, and maybe you can tell that we're going to use those if-then statements a lot.
When your cable company keeps you on hold, you get angry. When you get angry, you go blow off steam. When you go blow off steam, accidents happen. When accidents happen, you get an eye patch. When you get an eye patch, people think you're tough. When people think you're tough, people want to see how tough. And when people want to see how tough, you wake up in a roadside ditch. Don't wake up in a roadside ditch. Get rid of cable and upgrade to DirecTV. Call 1-800-DirecTV.
I'm going to use our activity from the other day to explain 2 laws of logic that you'll need to know. The first one is called the law of detachment. It says, if the hypothesis of a conditional is true, then the conclusion is true. And we had a conditional in our game, lots of conditionals actually. This one was called the fish swim theorem. It said, if something is a fish, then it swims. And we used that because we knew that the if part of our statement was true when we found out that Ralph was a fish. Since we knew that Ralph is a fish, then we can make a conclusion that Ralph swims. An important thing to remember is that we only make a conclusion here when the hypothesis comes true. That was the only time we would select one of these cards to use, is if we knew it connected to something that was already true. So again, only making a conclusion when the if part, the hypothesis, comes true. The law of syllogism. This one sounds a little complicated. Given that if P then Q and if Q then R are both true, then if P then R is true. This law just says that you can hook 2 if-then statements together as long as the conclusion of the first matches the hypothesis of the second. And we've already done this. You know how to do this. This one says if someone is at the mall, then the person must buy an Orange Julius. And if the person buys an Orange Julius, then the person gets a receipt. So we would write a new if-then statement using the law of syllogism that says, if someone is at the mall, then the person gets a receipt. So it's basically just cutting out this middleman and skipping from the original hypothesis all the way to the end conclusion. Law of syllogism. Let's focus first on the law of detachment. If a person has a job, then he or she pays income tax. That's our fact that we start with, our postulate or our theorem. And then we get this information. Rachel works at Taco Bell. What conclusion can we make? What you should ask yourself is, did the if part of that statement come true? And I would say yes. It says if a person has a job. We know Rachel has a job. She works at Taco Bell. So then we can make a conclusion using the law of detachment that Rachel pays income tax. The next one, if a dog has fleas, then he has to have a bath. Fido had to have a bath. What did we find out? We found out, did we find out that the if part came true? That's not the information they gave us, was it? They told us that Fido had to have a bath. The tricky part is that we cannot make a conclusion using the law of detachment unless we know that this part came true. Remember, on our activity, we only hooked things up if it matched on the front. And so we would say no conclusion here. And we could try to explain that, oh, Fido maybe had a bath because he was muddy. But really, if you just stick to the if and the then, you won't go wrong. Next, if Joe does his homework, then he gets to play video games. What if you found out that Joe didn't do his homework? I think we naturally would think, oh, he doesn't get to play video games. That might be our inductive reasoning working. What we want to think of, do we know that the if part came true? We only make a conclusion when the if part came true. So in this case, the if part came false. That sounds funny. The if part is false, so we do not make a conclusion. No conclusion. Maybe you got to play video games anyway. We don't know. So again, always checking the if part. In this one, the if part was true. In this one, the if part was, they didn't give us any info. And in this part, the if part was false. And we only make our conclusion when the if part is true.
When your cable company keeps you on hold, you get angry. When you get angry, you go blow off steam. When you go blow off steam, accidents happen. When accidents happen, you get an eye patch. When you get an eye patch, people think you're tough. When people think you're tough, people want to see how tough. And when people want to see how tough, you wake up in a roadside ditch. Don't wake up in a roadside ditch. Get rid of cable and upgrade to DirecTV. Call 1-800-DirecTV.
Let's practice the law of syllogism. We're going to write a new conditional, a new if-then statement. If Tanya jumps Jake, then Jake will go out with Renae. If Jake goes out with Renae, then Tanya will just die. So do you see where this connects? The connecting statement is Jake will go out with Renae. So we are going to take the original if, skip that middle part and go to the final then, and that's our new conditional. If Tanya dumps Jake, then Tanya will just die. Let's try another one. If angles are acute, then they measure less than 90 degrees. If angles have a complement, then they are acute. So it might have even made more sense that links those two statements around together in the beginning. We've got the then they are acute linking to the if angles are acute. So what we're going to do is we're going to cut out that middle part. These are kind of written backwards though, right? The if part is right here, and the then part is right here. If angles have a complement, then they measure less than 90 degrees. That was a new conditional using the law of syllogism. Last one, if the dog barks, then the baby wakes up. If the phone rings, then the baby wakes up. So I see that these two are matching each other. But it's not the kind of matching we need. It doesn't form sort of a chain reaction. This one has the dog barking leading to the baby waking up, but we don't have anything that comes off of the baby waking up. We would need that to say if the baby wakes up, then something happens. So it doesn't really work to form a new conditional if the thens are linking up. We can't really use that. So we would say, since the law of syllogism does not apply. A little more law of syllogism. This time we're going to try to make a conclusion, kind of like we did with those detachment ones. But this time we're going to go one step further and use syllogism. If Peter eats lunch, then he eats a sandwich. If Peter eats a sandwich, then he will eat a cookie. What if you found out that Peter ate lunch today? Peter ate lunch today, so then he ate a sandwich, and since he ate a sandwich, then he eats a cookie. We're going to cut out that part about the sandwich and go all the way to the end, and our conclusion is that Peter will eat a cookie. Next one. If we win our next two games, then we will make the playoffs. If we make the playoffs, then we will get at least 6th place. We got 4th place. So this one's a little different, right? On the first one, we found out that that original if part was true, right? Peter ate lunch. This time, we're finding out that that final part is true. And that means that we are not allowed to make a conclusion. Remember, we only make conclusions when we start out with this knowledge and it leads us to the end. So for this one, we would make no conclusion. In fact, the only way we could make a conclusion using syllogism here is if we found out that we won our next 2 games. That's the only way that syllogism would draw us to that final conclusion. It's important that we know the difference between inductive and deductive reasoning. Remember, inductive was using the patterns, and deductive is using more if-then statements. Well, here's a rule. The sum of an even and an odd number is always odd. And there's 2 ways to justify that, to think about that. Inductive reasoning would have you using examples, finding a pattern. So taking an even number and adding it to an odd number and seeing what kind of sum you get. That time I got an odd. Taking an even number plus an odd number. How many examples would it take to convince you that this is true? Some people are more skeptical than others. I need a lot more than most people, maybe, because I've been burned too many times. So far I'm seeing that at least 4 times it has come out that the sum is odd. Now, deductive reasoning is doing more of a, I suppose, a mathematical way of showing that definitely it's going to be true. You won't have to do anything this fancy, but I think it's fun to just see it done once. So here's how mathematicians would use deductive reasoning to show that that's got to be true. You know how even numbers are always multiples of 2, right? Can you get behind that? Every even number is 2 times something, right? So I'm just going to say that this even number is 2 times a mystery number, m. And then an odd number, let's see if we can get behind this idea. An odd number is always 1 more than an even number, right? This one's 1 more than 6, 1 more than 4, 1 more than 0, which I guess is even, 1 more than 2, which is even. So our odd numbers can be represented as an even number, and I'm going to use 2 times n as the mystery number, plus 1. That's 1 more than an even number. What happens when I take the sum of those 2? If I take my even number plus my odd number, well, do you remember how to factor out, kind of undistribute a 2 right here? Divide a 2 out of both of those. And what we have now is 2 times some number plus 1. And 2 times some number is always even. And if you take an even plus 1, what does that always give us? That gives us an odd number. So this is using sort of a systematic, logical path. You can't really argue with this one. And nobody's going to be able to throw down a counterexample because I showed that any old even plus any old odd always comes out odd. She was using an if-then statement, really. It was true. If someone's a sophomore, then they take English too. Let's see if you can tell the difference between inductive and deductive reasoning. Jenny knows that all sophomores take English too. Since Mary is a sophomore, Jenny knows that Mary takes English too. To me, I don't think that she was looking at a pattern, she was looking at a rule. All sophomores take English too. All of the students in Jenny's Art 1 class are freshmen. Jenny thinks that only freshmen can take Art 1. She didn't read that rule anymore. She was kind of just observing that everyone in her class was a freshman, so she made the conclusion, and she might be right, that only freshmen can take Art 1, but she was using her observation, so that's inductive reasoning. Okay, here's the tiebreaker. Jenny has never been pulled over for going 2 miles per hour above the speed limit. Jenny tells her friend that the police don't care if you're only going 2 over the speed limit. Was she going on a pattern of observations, or was she going on laws and rules? And I would say, in her experience, she's never been pulled over. but there's no law in the books that she is citing. So that is inductive reasoning.